quite a long story. I've only got 20 minutes, so I'll compress it down to probably 1 year per minute, I think. Uh, our approach here is I think we're all in the same sort of community where we're looking at peer-to-peer systems, peer-to-peer cash or whatever through blockchain, and systems that basically give back control to people and hopefully maintain privacy for people. And our sort of dream in MaidSafe is this privacy, security, and freedom for all of the people in the world. Hopefully, we used to say the digital world, but I think that's the whole world. And Bitcoin, when Bitcoin came along, it opened a lot of doors for us because people could see that peer-to-peer networking of any kind was actually possible. Before Bitcoin, there was a lot of peer-to-peer net, like Freenet was attempted. There was BitTorrent, Napster, music sharing, as we all know. Lots of different attempts, lots of technical issues, lots of political issues, lots of regulation issues. A lot of issues that prevent a lot of peer-to-peer solutions from working. So Bitcoin came out and it was exceptional for us, and it showed that for a transactional based system, so a system with small transactions, you can actually use sort of game theory and greed or whatever of miners to maintain on a peer-to-peer network a centralized data system. And the centralized data component is obviously a blockchain, which is fine, it works. And that peer-to-peer network's very successful. People talk about it solved the Byzantine general problem, which is not true. The Byzantine general did not solve his problem by screaming at the top of his voice, attack now. Bitcoin shows everybody everything that's going on, and that's how it works. It's an agreement on that particular ledger. And the reason it does work is because of that ledger and because of all of the miners. Unfortunately, they use a lot of power, but we know things like Ethereum have come along with a different mechanism which hopefully helps with that power. But even helping with that power, like there is still a blockchain, and that's a centralized data component. That is okay for transactions, and it's not very good for lots of transactions. It's not very good for many small transactions, but with the L2, L3 type systems to help there. None of that helps data directly. And there's been a few projects who have tried to jump on, like people jump on technologies, they jump on the blockchain. Now we're going to store all of our data, peer-to-peer networks work. And a blockchain is not a data storage mechanism, it's a payment mechanism. And we use a blockchain payment mechanism. We don't really care what mechanism we use a peer-to-peer mechanism for payments, because we know that peer-to-peer payments are now possible. And even better, some of the regulators and governments don't want to put us in jail for using them. If you're not in the UK, that is. So data is a different beast. Data is something that's not a transactional system. It can be. You can get transactional data, but data's a big thing. Data's great big huge lumps of information that we can't have every computer or every miner sharing. Data by its very definition, if you map data to knowledge, data is something that pieces of it sit across the network, sometimes linked, like with HTTP, sometimes private, like with your own private photos or whatever. So data can't fit the same peer-to-peer design as Bitcoin can fit. Data also has got another thing that's dissimilar to Bitcoin or a lot of cryptocurrency, where you can have the transaction. In fact, in many cases, you want the transactions to be open so that you can audit the chain. Which, by the way, is a brilliant future. If somebody can figure out how to make perfect software that is mathematically provably correct, that you can show that every coin that you produce is a valid coin and a valid token, and that can be transferred in a valid way without auditing, then you don't need a blockchain. That's something that people should work on with money. But in our situation, for data, we have to do something completely different. And as I say, data, some of it's open, like HTTP, like websites, you want them to be open. Public data, you want that to be open. Public software, GitHub type repositories, you want them to be open. Hopefully every bit of software is open all of the time. But there's also private data. There is your private photos, there's private company information and whatnot. And it's a huge, huge amount of stuff. And because we don't want to open, a bit like Bitcoin, there's two things that we need to be aware of at the moment, and this is a bit of research type territory that we're in. One is quantum computing, which obviously Bitcoin has to be aware of as well, that ED25519 and some of the DSA type keys are just one clock tick to expose those. At the moment, it's unlikely that you'll reverse a hash with that. It's unlikely that you'll be able to solve with quantum computing symmetric cryptography. But current asymmetric stuff, we do have to take care of. And for data, for information that's not currently in the open, like a Bitcoin blockchain, we need to be very, very aware. For the Bitcoin blockchain, you obviously want to make sure that you don't have a quantum computer coming along and exposing everybody's private key. For Bitcoin and things like that, it's not an issue. You just transition away to a quantum proof lattice type thing or whatever. We've got some projects at the moment using dilithium signatures, which is great because it sounds like something out of Star Trek. So you can actually look at the quantum computing side and say, right, if you want data and you want it to be secured forever, you're going to have to put it somewhere. And unlike Bitcoin, data is at rest. If data is sitting at the moment and a quantum computer comes along and is able to decrypt it, that's an issue. If Bitcoin at the moment is sitting in transitions to post-quantum cryptography and then people expose the old classical keys, it's not an issue because that old blockchain is useless. Data still would be a problem. If that data held, I don't know, some very private information you had, we can't solve the quantum computing problem the same way that Bitcoin can solve it. The other issue that we have to be aware of is AI, and AI potentially solving maths. And AI potentially solving maths might mean things like even AES, whatever ECB or GSM, whatever cipher you want to use, that could be potentially broken with an AI, an advanced, an AI that becomes advanced enough to crack parts of maths. And I don't know if you've seen what it did with the Navier-Stokes equations recently, but it's something to be concerned about. So data has to be beyond encryption. Like, we have to secure data beyond encryption. That's one thing. We have to secure it beyond current encryption. We probably have to secure it beyond post-quantum encryption, because the AI potentially that could solve maths, that it could break S1 boxes in an ES algorithm or even poly-cha-cha type algorithm, is very likely to also break quantum proof or post-quantum asymmetric cryptography. These things are all pretty important. They're extremely important. They're important for us, they're important for the world, but when you're designing a network, you care about you and you care about your users, and we have to consider those things. So the Autonomi network from day one made a decision that data would be secured beyond two big decisions that we made. We would secure data beyond encryption, and also we would take out the human in the middle. So you'll see some projects will say, "Are we a peer-to-peer like network? We use a blockchain, which central to the data thing, and we allow someone to create a contract with someone else on the planet to store their data and blah blah." And our approach is that human in the middle can't be in the middle. So the network has to decide the price of the data. The network has to ensure that people are looking after the data. And people storing data should have no idea what they're storing and no idea who they're storing it for. And that's quite a critical thing. Both of those are solved by an algorithm that we call self-encryption, which is basically a sort of convergent encryption algorithm where data goes into the algorithm, it's split up into chunks. Those chunks are compressed, which is sort of irrelevant. It's just a time saver. Then they go through an ES algorithm, ES-GSM. We encrypt those chunks using AES, not to encrypt them, but to ensure that none of the output is repeatable, which is exactly what a symmetric algorithm will do. Even if you could reverse it, you get non-repeatable output. And then that output then is hashed with the pre-encryption chunk of a different part of the file. So basically what you get there is a phenomenal argument in a debate with university professors over is that a one-time pad or not? It's not a Shannon one-time pad for sure, but it's potentially a Legionnaire one-time pad. But you get data that is encrypted beyond encryption. It's irreversible. It's what you call information theoretically secure. With a chunk of data, there's not enough information to decrypt it. So it doesn't matter if you're a quant or an AI or whatever, you can't decrypt that information. And that's a key tenet of the autonomy network. And on top of that, these chunks, as they're stored onto the network, people are running a node. And when you're running a node on the network, chunks of data will come to you and you will be paid, like the person uploading pays a particular part of the network. When that happens, when data is stored somewhere else, you'll be paid. And your node will be paid based on its behavior, if it's been there long enough, if it's already looking after existing data, and it's accepting new data and then giving that data out. And what that means is, it's another thing that we were very keen on. When you store data on this network, it's stored forever. You pay once and it's stored forever. If you put a website up, it's stored forever. It can't be brought back down again. Of course, that gives you lots and lots of issues because we don't know who our customers are. We've got no control over our customers, but that's exactly the way a true peer-to-peer network should be. The fact then that no data can be taken off the network is good, but everything's yin-yang. So people will say, oh my God, there might be terrible stuff there. And well, that's possible, but you shouldn't look at that kind of stuff. So there's you come across all sorts of debates all the way through, but basically what we want to do is have a permanent, secure beyond any level of attack data network that is open to the world, and anybody can use, nobody can be banned from it, nobody can be censored on it, data can't be removed from it. And the idea there is to, well, as we said, I spoke to Brewster Kale from the Internet Archive and told him one of our things is to put him out of business. And really, we should try and put him out of business, and he'd be the happiest man in the world if we did put him out of business. So the whole thing is we're all involved in this sort of peer-to-peer sort of march, if you like. So we've got transactional information seems to be pretty well handled at the moment with Bitcoin, Ethereum, and various things on top of that, but that is a transactional system. There is a common data type in each of those networks. We've got data, which again has got a different set of parameters in terms of security, persistence. We're going to have AI, we're going to have compute, we're not going to do that. The other thing about peer-to-peer networks, which I think everybody should really be aware of, is you're a cog in the wheel. You're not the wheel. You're a cog in the machine, and you have to work with other cogs. And we all have to work together as teams, and we have to work in hopefully harmony and find out what other people are doing and how they're doing it. And even throughout this project, we've been at it for 18 years, 19 years or something now, is if somebody was doing it better than us, we would just join their project. And it's not about winning as a project or winning as a team or winning even as Scotland, which I'd love Scotland to do some brilliant things here. It's about moving society forward and trying to do that in as an unbiased way as possible while working with everybody you possibly can and learning from whoever you can. So hopefully, I know I went over slightly there, but hopefully I got through a little bit and left time for questions. I'm sure I told you pretty much nothing about the network, but you can certainly go through the questions.
Amazing. Thank you so much.
Okay, I will ask the first two questions. So tell us, okay, what are your typical customers that love to use this, like in the world? And then number two, what do you think of Filecoin? These are my two questions.
What was the second one? Sorry.
Coin. What do you think of Filecoin?
Filecoin. All right, yeah. So the customers for this network are basically, we hope it's everybody, but we won't know who those customers are. At the moment, our sort of drive is towards developers who are developing applications on top of it. So there's a Friends network, which is a peer-to-peer communication system. There's things that look a bit like Facebook on top of it. There's also apps to upload data from organizations, where there'll be an organization screen, the data can be stored there. There's another company who are doing password lists, and they're storing password lists on there. So that the actual users of it are sort of unknown to us. We're trying to promote everybody doing everything and see what happens. So we don't really know. Filecoin's very interesting because the chap there, when they came out with the paper, because they were trying to meet me beforehand, and when I read the paper, I thought, oh my God, that's exactly what we're doing. That's brilliant. And then, but they got a huge amount of money. They got like £250 million of dollars, and they put quite a lot of research into libp2p, which is a peer-to-peer networking layer. Really a vital thing, and it's brilliant that they did that. I think they've withdrawn some of that support now. But one of the main issues that anybody involved in the peer-to-peer networking or peer-to-peer projects should be aware of, NAT traversal, IPv4, having routers at home is a horrible thing. And if there's one thing that, if you were a controlling entity like a government or a large corporation, you'd want that to stay that way, and you'd want libp2p and projects like that to fail. libp2p hasn't solved the NAT traversal issue. It was on its way to, some of that funding has been removed from it now, which is very sad. We've got some projects in research where we're doing quick native NAT traversal, and so far we've had like 100% success in traversing NATs. That's through carrier grade NAT. symmetric to symmetric, symmetric to port restricted and whatnot. And that's a huge deal. It's a boring deal. It's one of those things that should work. And it's one of those things, if you're doing a project in the peer-to-peer space, you'll never expect it, but it's a brick wall that you'll hit like face on. And we have to solve that issue. Nobody will get paid for solving that. Nobody will get thanked for solving it. I know we're doing a lot of work and people will just think, oh, well, that's good, it's working. But it's one of the biggest blockers we've got. So Filecoin have been great there. Where I'm not so sure about Filecoin is they have gone a bit like Ethereum in many ways, into some deep science about cryptography and snarks, ZK proofs and whatnot, and complicated things in a way which I don't think a data network should. One of the key parts of our network is you can run it on a Raspberry Pi or on your mobile phone, and the idea is you get some. My sort of thing that I keep thinking about is this little girl in Africa jumped out from behind a bush, running a computer, an old computer she's found somewhere, earning a little bit of money, being able to get involved in the whole digital world and the world that we all know. Filecoin, unfortunately, to run one of those things costs thousands and tens of thousands. So the minor part of it, a little bit like the sad part of Bitcoin at the moment, that is becoming very corporate, and it's sort of anti peer-to-peer in many ways. But they've got some super smart guys there, and I really hope that some of the work that we are doing, which is a lot of our work would be more like what you would see in the earlier versions of Avalanche with a DAG-based network instead of a blockchain, but the DAG becomes unworkable. And Algorand, we do that kind of thing where we're looking at how can you use the best accessible mathematics and mix it with the most commodity hardware to get as many ordinary people involved. And Filecoin, I think, unfortunately, have went very much for a larger, more corporate miner. But we've got to try every angle, and maybe their angle's correct. Who knows?
Any more questions? You can come forward and ask. You have to ask something. Hi, David. I'm curious to ask your opinion about the Bitcoin. And since you're talking on the subject, I have a friend who is working on his own LLM models, and he's trying to work on the quantum computing as well. And what he said was that apparently 21 million Bitcoins is not a limit once the quantum computing comes into play. What's your thoughts on that? And also, what would you recommend for the average Joe to prepare his portfolio for the upcoming quantum computing boom? Thank you.
Yeah, I think the quantum computing thing is very interesting. My own impression with it is it's more likely the LLMs, maybe not the way that the autoregressive LLMs at the moment, but perhaps that maths will move forward quicker. So quantum computing will solve some issues like decrypting keys very, very quickly. So where you're taking an array and you're wondering what if we could analyze that array being every bit being a 1 or a 0 at the same time. They're not very good for general computation. In fact, they're terrible at general computation. But LLMs are probably more likely to be more of an issue for encryption and mathematical things, at the same time as being a phenomenal tool to use. The way that technology is moving, I've been involved for quite a while in neuroevolution and spiking neural networks and this kind of thing, which interestingly now is coming back into the LLM arena. A Chinese lab today came out with a spiking neural network approach, which reduces the energy requirement by a factor of 1,000. So I think the LLMs are more like, they're more general computation, if you like, computation quotes. I would be more concerned about them progressing through mathematics and cryptography quicker. If quantum comes along, by the time it comes along, and it could crack a lot of the classical keys, we already have post-quantum cryptography, but the LLMs are more likely to give us even stronger post-quantum cryptography, in my opinion anyway.
Any more questions? Right.
Excellent. Well, but just finally, just how can people like follow your work, either maybe on LinkedIn or X or website or?
Autonomi.com, autonomy with an I, is the company, and on X, it's like you can find me at Meta Questions. That's where I ask
Amazing
questions.
Amazing, excellent. Thank you so much for your excellent talk and for answering the questions. Thank you so much.
No problem at all. Thank you. Thanks, everyone.